Hello and welcome. In this lecture, we are going to be setting up the link between the mover and the trigger using a technique called dependency injection, so that by the end of the lecture, if we stick the gargoyle in, then the door moves down, or at least partially does. Let's dive in and see how this works. In our grabber CPP, we've seen that there is a dependency, what we call a dependency, for the physics handle. This grabber cannot do its work unless you have a physics handle component somewhere around. Now, it just so happens that the trigger component is the same. The trigger component, in order to do its work properly, needs to have access to a mover component. However, it's a little bit trickier in this case because, sure, in the case of our secret door, the trigger and the moving object are within the same actor. So you could get an object by finding a component of type on the actor. But what if, and we will have this situation in my crypt, where I want my trigger to be on a different part of the room from the actor that is moving? Well, to allow for that kind of flexibility, we want it such that the trigger doesn't have to go and find its own dependencies. And there's actually a name for this kind of programming concept. It's called dependency injection. Basically, it's in the case where we've got something that says, I need another object, but I can't find it myself, or I don't want to find it myself. And it's often sensible to not leave it up to the object that's doing its own job, making it have another job of trying to get hold of an object. So the way we can do this is to create a mechanism for blueprints to tell the trigger component where to find a mover. And the way we're going to do this is by creating a blueprint callable function on our trigger component.h. So it's going to be public. We're going to put it in the public section underneath the tick component. And it's going to be a U function so that it can be then in the parentheses blueprint callable. And there doesn't need to be much to this function. It's going to be void because it don't need it to return anything, but it's going to be set mover. So it's going to set a link to the mover, and in order for it to set a link to the mover, it needs to take in a pointer to a mover component. So that's going to be U mover star, and we can just call this the mover, like so. Put a semicolon at the end of that line. And we need to store this somewhere. So we're going to create a new private variable. It's not going to be a U property, and it's just going to be a U mover pointer, which we're going to call mover as well, like so. And what we're going to do is implement this set mover over in the CPP so that it sets this mover pointer, which by default is going to be null. And we do have to do one more thing. We have to include the header file for our mover. Now, in this case, because the header file is in the same folder as the trigger component, all we have to do is hash include quote mover.h. And that's going to make sure that the trigger component is aware of the mover type. So let's go over into our trigger component CPP, and I'm going to put this below our tick component that we're going to implement set mover. We're going to put the class uTrigger component before, unindent it, remove the semicolon and add braces, and essentially all we're going to have to do here, let's change the name just in the C++ file. It doesn't actually matter whether the name of the parameters matches between header and C++, so we can change it here and say that the new mover is what's coming in to set mover. And so we can set our local variable, our class variable mover, equal to the new mover, like so. Now, because these new functions don't always show up with live coding changes, I'm going to close down the editor, recompile from Visual Studio Code, and then relaunch from the U project. Now let's go to the content drawer, open up our secret wall blueprint, and then from our begin play node in the event graph, let's pull off of here and search for set mover. Now notice there are two options here. One, it would be to set the component, which is also called mover, and one is a function on the trigger component. So we want to select the one that's a function on the trigger component, And then what we want to do is drag in our mover component as the other argument to this function. And that should do the trick. It's set the mover at begin play. So now essentially what we want to happen is that our trigger component should be setting and unsetting the should move Boolean in here. So that's going to be my challenge to you, to create some public functions in mover.h and mover.cpp. It should be set should move, and it should update that uProperty variable. In fact, you can make it not a uProperty anymore because we're going to be setting it through code now. And then you can put it in the public section. It needs to be public because we're going to try and access it from our trigger component. And you can call it on the mover pointer that we've got in the trigger component from its tick component, setting the appropriate Boolean, whether we want it to unlock or lock again. Pause the video and have a go. Okay, welcome back. So I'm going to remove the uProperty from should move. I'm going to go to the public section just under tick component, and I'm going to create a void set should move, taking in a Boolean, which we're going to call should move, like so. And then we're going to take this and go over to the mover CPP and implement it, replacing the semicolon, adding in the uMover : class. And then basically, again, we can call this the new should move, and we can say that should move equals new should move. Now, you might be wondering, why don't we just make the variables themselves publicly accessible so that we can set those directly? That's generally not good practice in C++, because if you let somebody change your variables, you never know what could be happening to them. Whereas if you have a method there to do it for you, it allows you later on to change how you structure internal variables without having to change your public functions, which means there's fewer updates to different classes that you have to do. So generally, as a rule, we always use setters and getters if we need to access variables in other classes. So now that we've created that new function, let's go over into trigger component CPP, where we've currently got our log messages. What we want to do is access our mover pointer. So we're going to do mover arrow set should move. And in the case where we've got an acceptable actor, that should be true. We should move, semicolon at the end of the line. And in the else case, well, then we probably shouldn't. So we're going to do mover arrow set should move, and in parentheses we put false. Remove that extra R that I had on the end of my method, and let's recompile. Now in this case, because I've only added this function in C++ land and it's not blueprint callable, I don't think I need to actually restart the editor for this functionality to work. Close down our output log, go towards our gargoyle and start playing, and pick him up. Let's go out of this cage and stick it in the alcove. And there you go. It's moving down, but it stops as soon as the gargoyle falls out, which is not ideal because the gargoyle is not really held in place and the wall isn't fully down. And because it's simulating physics, it's going to get popped out of that alcove, isn't it? So what we need to do is make sure once we drop it into our trigger area, it gets fixed in there and just stays. So that's going to be the subject of the next lecture. I'll see you there.